So, hi guys, once again, good morning, and we'll be starting without wasting time complex numbers, which is the next chapter after quadratic equations. The very first formula is if there is a complex number, you know it will always be of this form, and this complex number has a modulus and an argument. It's a way to represent uh, this sort of thing. Suppose this is the equation and this is something like that. So the angle it's going is the argument basically, and this is r and this is your modulus. So the length of the line, it can be this or this. So you, whatever you have to measure it. Suppose from this it's going this, so you have to measure this will be the r. It will depend on this for sure. There's a formula for the rotation of the complex number that we will cover later, but right now just the modulus. So yes, just the modulus for this. This is, if this is equation, its modulus will be somewhat this way. Why? Because when we are considering about complex number, then this equation, that is y-axis and this is x-axis, this is real number and this is imaginary. This is called eigenplane. For complex number, to denote complex number, you use not normal plane but normal xy plane. We don't use that. We use complex, which is eigenplane, we name it specifically. So yeah, modulus is simply denoted by this. This is how you find the modulus, and this can be also represented as this. If something like this, that means it's, we're talking about its modulus. Then is argument. So argument is, I told you, theta. So you can find it like that. The cos theta is this and sin theta is this. So definitely theta is equals to cos inverse x upon under root x square plus y square. This is important. You should remember it because questions sometimes are asked directly in NDA, in CUET somewhere in easier ways, and sometimes in mains also based on this. Basically, I'll cover mains for JEE people. I would cover mains for sure, and for advanced, if you want, please do let me know, because it's more like, for advanced you want something better, like for international olympiad of physics, international olympiad of math, the things become complex. So for that we have different formulas, and I have those formulas and I can give you if you want to wish. So next is the conjugate, but for sure before that, see some, the second one, these are some of the properties that we have. So I is nothing but I is equals to under root minus 1. We all know this. So it's just that if you 4n something like that is there, then it be always be 1. Like if it will be multiple of 4, it will always be 1. If it is multiple of 4 plus 1, it will be I. And if it's plus 2, then will become minus 1, and 4 and plus 8 will become minus I. And I don't think I need to go further in detail to explain this, because it's very easy. Even class 6 student will understand it. So z1 is equals to a plus ib, and z2 is equals to, if these are the two complex number given, then we can, if z1 and z2 are equal, then we will identify it with the two different real and imaginary. So real will be always be compared with the real term of another complex number, and the imaginary part will be compared to the imaginary part of the second number. Okay, so yeah, this is the way. So here we're comparing a real part with the real part, that is a is equals to c, and imaginary part with the imaginary part, that is b is equals to d. And when we add that, we add the real part together and then the imaginary part. That's what I said, you cannot add an imaginary and a real part. That's why it's written like that. Okay, so that's why we add differently. And when we multiply, then we also consider the complex with the imaginary. Like this is AC, then it is AD, BD, then it is again AD, and then it is BC. So you can see we are multiplying imaginary with the real also. So this is how we multiply. And if you want to find its inverse, then it's simple this way. It's also called multiplicative inverse. It's simple. So this is how we find inverse. These are the formulas. Just go through it. It's very simple. If you would have studied it, it's the basic. Conjugate. Conjugate is nothing, just we describe it with a bar of z. This is simply conjugate, and when you're finding conjugate, like this is the z. Suppose this is z, then when you find its conjugate, then it becomes z conjugate is equals to a minus iv. Only this sign will change. Like here, as we have said, the sign is becoming negative. Yeah, that's it. So some of the properties of conjugates are like z bar ka bar is always z. Like if you're going to find its conjugate and again find the conjugate of the conjugate, it will become the real number you'll get. If you add this and this, we'll always get the twice of the real number part of the z. Why? Because it's very easy. You can even imagine it saying it this. Z minus z bar is equals to minus no, not minus, but 2i imaginary part of z. And if these are equal, then it's purely imaginary, and if it is 0, then it's purely imaginary, and if it is z, it's purely real. And these are the properties. Just go through it one by one and you'll realize it. Z bar is equals to z bar square. This is modulus. You're finding its modulus and then you're squaring it. You remember modulus? This was the modulus. After squaring, it becomes x squared plus y squared. Just z1 plus z2, if you find the conjugate of that, then it becomes z1 plus z2, and if you multiply z1 z2 throughout the conjugate, these are the properties you'll use while proving some of the equations or some of the questions. Okay, so complex number was always one of the most difficult chapters for me, at least, and when I was in 11th and 12th. But because this part is very easy when you're proving parts, by using these 1 2 3 4 5 formulas. But when you go deep for advanced level, it becomes really difficult, because then you use geometry. Without geometry, you cannot solve some of the complex based questions. That's why sometimes I cannot imagine it. The imagination needed in this chapter is really high. So for that, you need to be really practiced. But yeah, the easier part is very easy. Yeah, just the difficult questions become very difficult. But there's some questions are really easy and they can be done in 1 minute, and it's very easy. So yes, z, again, some of the formulas. Z bar is 0, then z will be equal to 0, and these are the properties of the modulus functions. Then z is equals to minus z is equals to z bar, because when it is modulus, then you're finding x squared plus y squared under root, and so minus doesn't matter. Yeah, so the next is this one, that if you multiply two complex numbers, it will be, and then put mod on it, it will be z1 mod and then z2 mod. If you divide it, that is z1 mod upon z2 mod, and this will be mod az1 plus bz1 ka whole square when you're doing it. So a squared z1 ka square plus b squared z2 ka square plus 2ab, and then the real part of z1 and z2. This is important. Why? Because most of the people forget this one. They don't use this one, or because this is important, and there will be only real part. Just go through this, only real part. So this is important one. Just remember it very nicely, because these things you always using it, so you remember it. But this one is useful, but you don't remember it. You get confused, most of the students. z1 plus z2 is always less than z1 mod plus z2 mod. It's always less than. You can go through this from this way only. z1 minus z2 is always greater than z1 minus z2, and if z plus 1 upon z is equals to k, then z mod is equals to this. This is basically what we have studied in the quadratic equations. It's the same thing. Just go through it. It's not that important, but you should know. You don't know when the questions are going to ask and when it will be useful. Next is the argument properties. These are the properties about the angle. Argument basically means the angle to which the line is rotated. So yeah, a plus ib and the alpha. This is alpha. You can say it argument. The theta, yeah. So argument will be represented by theta alpha. You can see as anything. So the theta is the argument in z. Then theta is equals to alpha if z lies in the first quadrant. It will be pi minus alpha if z lies in the second quadrant. Alpha minus pi z lies in the third quadrant. Minus alpha z lies in the fourth quadrant. Argument of z1 and z2 is equal to argument of z1 plus this is equal, if k1 is equals to -1, argument z plus z2 is always greater than pi. These are the properties that you need to remember, and you don't know when you're going to use these one. So look at it once. And if k is equals to 1, then you can directly get this line. You don't know in what question you're going to use what conditions. So remember all things. Though it's not that important for NDA, for CA2, these things are not important. This is basically for JE, or if JE Advanced you're going to know. Not that much useful, just I want to say, but you should know, since I'm not missing anything out. Z and yeah, if this you're dividing it, then arguments just get subtracted, and if you're multiplying it, then the arguments get added up. If k is equals to -1, k is equals to 1, k is equals to 0, these are the equations. Okay, I hope you're getting it. Then we have argument z1 plus argument z2. If these twos are equal, then for sure that is z1 plus z2 is equals to z1 modulus plus z2 modulus. And if argument of z conjugate is equals to minus argument of z, this is also quite important. You can use it. Sometimes questions are asked on this, on the assertion and reasoning type questions, on these properties directly from the properties, so you should know. So argument of z is equals to 0, z is purely real, and argument of z is equals to pi by 2, then z is purely imaginary. You already know this thing. Argument of z minus argument of minus z is always equals to plus minus pi, and according to amplitude, that is according to the z, whether you'll get it whether it's positive pi or it's negative pi. And the last form is the polar form. How you basically, polar form is a way to represent your complex number, and it's mostly useful for rotation. When like this, it's rotated this line by theta angle anti-clockwise, and you should remember it always that whenever we're talking about rotation, we are always talking about it in anti-clockwise direction. In anti-clockwise direction, it's considered theta positive, and if you're considering clockwise, then you have to consider it negative. That's fine. We consider anti-clockwise because it's always healthy to use positive one. So if it is the complex number, r is the length of the straight line and theta is the angle to which it is rotated, then you can write this as this. This is polar form, Euler form, anything you can write, or the rotation theorem. I brought this because I thought it would be really useful for this term, because see, it's the same thing. We are using Euler's formula in this only, but see, I'm just trying to tell you when it will be negative here, like see, it will be negative, or when it will be positive. In first case, we can see this is going to this, as you can see the arrow, it's anti-clockwise direction, that's why it is positive here. This is z2. This we are taking it to this side. This is taking to this side. That's why it is z2 we are calculating, and it's anti-clockwise. And here z1, from z2 to z1 we are going, so it is clockwise we are going. That's why it is negative. I hope you understand this, because this will be very useful when you will do complicated questions. Then this is going to help you a lot, because most of the students, they get confused in it. And if you don't, I hope you don't, because I was even getting confused in these terms, which is basically very, 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 very stupid. It's a blunder if you do that. Again, this is something that I was talking about. These are the rules that I already told. So the next is 8. That is the square root. We know that this is the how we find the square root. Some terms, I hope you just get it because it's important. Okay, then cube root of unity. If you, let's learn it. Okay, this is the properties, you should know it. You don't know when you're going to use it, and it's important for in most of the questions, and very rarely questions are asked on this. But if questions will come, though, you cannot solve without using that, because it's going to take you a huge time, like ages, to come to this, right? Directly, then it will be very useful for you. Cube root of unity. Suppose this is something. So in cube root of unity, we have 1 alpha and alpha square as the roots. So yes, this is something, the equations, it's equations, the roots will be this. Like, yeah, I told you. Here it's shown with omega. Okay. So don't confuse between alpha and omega. Omega are the roots only. So the omega square is always equals to 1. This is very important that I would like to tell you. Then 1 plus omega square is equals to 0. This is one more property. This if this is somewhat this way, 1 plus omega ki power n plus omega 2, and it becomes 3 or 0. It depends on n. If n is the multiple of 3, then it will be 3, and if it is not, it will be 0. 1 plus omega square, you can represent these as the lines of the quadrilateral triangle, like equilateral triangle, with using these three. If this is 1, this is omega, and this is omega square, here is represented as the forms of equilateral triangle. Then one more equation, one more property, that is omega conjugate is equals to omega square, and omega square conjugate is equals to omega. This is also important. Most of the people, they forget it, but this becomes very easy sometimes while solving some questions. Nth root of unity, like this was where before that we were talking about third cube root of unity. Now it's nth. So in nth we have 1 plus alpha squared plus like that. So yeah, 1 plus alpha plus this is equals to 0, and the highest power is always equals to 1. You can see here it's nth root, so the alpha ki power n is 1. And this was one more important property, and you can, yeah, these type of questions are asked a lot. I have seen PYQs in JEE this type, so if you're preparing for JEE, please go through it. M plus alpha square, if you're multiplying these type, m is nothing but a constant, any constant it can be, so you can see like again this type of only. So it equals to this. If instead of x we have m here, that's the only difference. De Moivre's theorem. This is also important, like polar form, and this is De Moivre's theorem. These two are one of the most important parts, because generally used in each and every question. If you're doing nice questions, it will be used generally. So cos theta plus I sin theta ki whole power n is always equals to cos n theta plus I sin n theta. This is important. And if it is this type, then cos theta plus I sin theta whole power n, this can be represented as this is the same thing. Then we're talking about the geometry. That's what I was saying, is geometry one of the most difficult parts, because I consider it the most difficult part of complex numbers. So if you want to excel in this, then try as much as question you can, because just by the formula definitely you cannot get it. Questions are really tricky in this, and you have to imagine the questions, then solve it. So z1 minus z2 represents the distance between the two complex numbers. If you've been asked like find the distance, you can use this formula. This is very like basic form. This is the basic, right? And like this is the circles equation. And after that, I would also tell you a trick to remember all the equation: ellipse, circle, straight line, this, that. That will be very simple through it. But right now, just go through it, because I don't want to miss anything. Z minus z1 is equals to z minus z2. This is simply the equation of the line bisector. These two are the same lines, right? Basically, it's this way. It is z1, it is z2, and the bisector z, right? So this is z1 and z2, there's a line joining it, and z is the bisector. So this is the equation for that. The equation, this represents circle, this is also represents circle with the center minus alpha, and the radius, this will be the radius. You know, like circles can be represented in many forms, so this is also one of the forms, and you will prove out this will be turned out this only if you will solve it later. Then again, the equation of this circle in terms of directly complex numbers, so you can, as one of the diameters, is when you are given diameter, then you can use this equation. When you given radius, then you can use this equation. So equations according to the situation, according to the questions, you will think like which equation you have to use. for circle. So if 4 points are given, like z1, z2, z3 and z4, and they are concyclic, then definitely this is something, this will always be purely real. I hope you can see it. This will always be purely real. You can prove this right now. I will not prove it, I'm just going through it. The questions come to prove this also in boards, I think. The point dividing the line joining z and z2 internally. Yeah, so if you have like a point is dividing a line joining z and z2, and if it is internally, this is the formula, and if it is external, this is the formula in the ratio m is 2, and I'm talking about in both the cases. Midpoint of the line can be found using this formula. This is very simple, like we had studied in normal geometry, right? So same goes for the complex geometry also. If you will go in detail, you'll see most of the formulas, they are same as you've studied in normal NCRT. But yeah, it will be different for sure, because we are talking about complex, so it will be complex for sure. Centroid of the triangle formed by z1, z2 and z3 is given by this equation. Again the same equation, I told you, no? The center of the triangle formed by this is given by this. In center is, you can get using this formula. The vertices of the equilateral triangle, if you're given the vertices, then you can definitely get the equation by that. And if you for vertices of a parallelogram are given, this is the equation for the parallelogram. Next, if you are given z1, z2, this, then it can, this is again the equation for the circle and rotation of the complex number that I already told you, but I didn't tell you this equation. So yeah, this is something you can represent in this form. I told you whether you use minus and positive, but this is an advanced version. You can write this as this for the rotation. If you are given the question that this is rotated, then you can use this one. And one very important formula that I would like to tell you is this. Suppose 1 plus z squared plus this, and where the z's are the roots, okay, this, so yeah, this is equals to z minus alpha 1, z minus alpha 2, z minus alpha 3, like this. So any equation can be written. If you don't know its roots, then you can write it this way. Sometimes you can also find the roots by this equation. This is one of the very most important equations that I thought of using a lot of questions when I was solving. This really helped me, so I thought, why not to tell you. So next I would be telling you the trick that I told you. This is the trick that I was talking about, like locus of the point. So yeah, this is the equation. If you have been given this equation, something like this, if the equation is, then if k is equals to this, you just can see if the equation what is given k, and like that. So if I'm not saying it will be directly this way, you may be given the complex number, like something like x plus iy, something this way. So you just have to use your mind, and this is just the general formula I'm telling you. So if k is not equal to z1 minus z2, then it will be ellipse. And if in this equation k is equals to z1 minus z2, then it will be line joining a, b and b, that is a straight line. And now if we subtract it, similar there, were adding, now we are subtracting. So if it is again equal to z minus z2, it will be hyperbola, and if it is equal to z1 minus z2, then it will be again a ray. Ray means you don't get the other point, you just have one starting point and you don't have the end point of it. That's the difference between line and ray. And now you just using two equations, you can, like, the equation for ellipse, for straight line, for hyperbola, and for the ray. I hope the trick helps you out the way it did to me. Next is this trick. If you're given something of this form, an equation of this form, z minus z1 upon z minus z2 ka whole modulus, plus this is plus, is equals to k, and if k is not equal to 1, it will be angle bisector. This equation will show you like the angle bisector equation. And if k is equals to 1, this will be represented as a circle. You can represent this line as a circle. So you just know that just the value of k, how difference it can create in complex equations. So geometry is quite interesting, but yeah, tricky too. Z plus z bar plus z minus z bar, if this is k, something is this form, then this will represent a square. This is the equation for the square. I hope you get it. And one more thing, that's we're talking about this, since I'm talking about everything. So what one more effective thing to distinguish this term, you can also say that this is the distance of z, a complex point, from the origin. From the origin, it will be this. You can represent it as this. This is also important because I was, for 2 days I was confused, like what is this, how to get this, but yeah, you will know it. Z minus z1 minus z2, the distance is from the that I already told you. And then the equation of the perpendicular bisector also I told you. See, this is something you can represent. This is something how it looks like. So this is basically what the equation for that is. I already told you the trick. I hope it helps you out. If it did, please do mention it. And this is somewhere I will end the chapter. I hope you like it, and it helps you out. Thank you.